Good morning, everybody, and thank you so much for joining me. So I am doing lesson 6-1, which is identifying and representing functions. And so the essential question is, how can you identify and represent functions? But first, let's watch the video.
Children's Hospital Boston is on the cutting edge of surgical technology. So advanced that they recruit help from the non-human kind. Meet Wally the robot. Wally was developed to assist doctors during surgical procedures. The tool attachments that Wally has, like this one, moves like a human wrist, but has the ability to reach areas of the body in a much less invasive way. That means less trauma to the patient, which means a much faster recovery time. And the coolest part of all is that Wally is remote control. Doctors can perform remote surgery on patients. Let's take a look. Just like a video game system, this one has a console. Each action or input has one result or output. We call this in math a functional relationship. Every time the doctor moves the controls in one direction, Wally translates this same action on the patient. And just like a video game, every action has the exact same reaction every time you make it. Functional relationships ensure that each input has exactly one output. So every time you push the jump button on a video game, your character jumps. And every time the surgeon moves to the right, Wally also moves to the right. Without a functional relationship, I sure wouldn't want Wally performing a surgery on me. And that's another reason math matters.
Awesome. And remember that we have a child, our hospital here too, that you guys have access to it. Okay. So, so anybody, a doctor from anywhere could have, the doctor could be in New York and you can have the surgery here in Fresno.
Let's work through an example that demonstrates how to identify and represent functions. Carlos needs to buy some new pencils from the school supply store. Carlos asks his classmates if they know the price for pencils. Angela says she bought 2 pencils for 50 cents. Paige bought 3 pencils for 75 cents. And Spencer bought 4 pencils for $1. Look at the table to see how this information can be represented. We know from the problem the price for 2 pencils. We also know from the problem the price for 3 and 4 pencils. You probably noticed that when the number of pencils increases by 1, the price of the pencils increases by 25 cents. What is the price of 1 pencil?
So you can see right here that for 2 pencils, you paid 50 cents. So 50 cents divided by 2 is 25 cents. And then you can also see that 75 cents divided by 3, that's 25 cents. So that means that each pencil is 25 cents, okay? So now we write it. Let me see, is it already written? Yep, so now you just got to check. The program
Not
is wrong.
quite. The price of the pencils increases by 25 cents, so the price of 1 pencil is 25 cents. Now try to identify a rule you can use for X pencils. You know that 1 pencil's price is 25 cents. Therefore, the price of any number X of pencils is a multiple of 25 cents. Carlos wants to buy 12 pencils. Let's use the rule to fill in the last row of the table to show how much Carlos will pay for 12 pencils.
So right there, so it's going to be 25 cents for each pencil. So if he's buying 12 pencils, it's going to be 0.25 times 12. So it's, what is it, $3?
Carlos will pay $3 for 12 pencils. What if Carlos decides to buy erasers in a package? There are 6 pencil top erasers in 2 packages of erasers. What rule would you use for the number of erasers Carlos gets when he buys X packages?
So he said what? They said six packages. So you would multiply the 3 times the X 3 per package. So it's multiplying the numbers, I think.
Correct. If there are 6 erasers in 2 packages, then there are 3 erasers in 1 package. So the number of erasers in X packages is equal to 3 times X.
And if you have any questions, if I confuse you, please let me know, okay?
A function assigns exactly one output to each input. The value that is put into a function is the input. The result is the output. Look at the input and output values shown on the mapping diagram. Since each input value is paired with only one output value, the relationship is a function. Let's look at another example. The input 2 has how many outputs? The input 2 has more than one output value. Since there is more than one output value, the relationship between the input value 2 and the output values 4 and 5 is not a function. Now it's your turn. Determine whether each set of input and output values is a function. Here's the first set.
So for me, this one, I always had a hard time knowing what was a function and what wasn't. So when they say input, think X. The input is the X, the output is the Y. And the only thing you got to remember, if there's 2 arrows coming out of the X, that means it is not a function. But if there's only one arrow for each of the x's, then that means it is a function, okay? So look at here. The 1 has only 1. The 2 has only 1 arrow. I'm sorry, the 3 has only 1 arrow. The 7 only has 1 arrow. So that means this is a function. Now let's take a look at the second one. The 0 has 1 arrow, but look at the 2 has 2 arrows. So that's why this relationship is not a function. So the example one, I see the 7 has 1 arrow, the 8 has 1 arrow, the 9 has 1 arrow, the 10 has 1 arrow. So they each have only 1 arrow. So this is a function, okay? This relationship is a function.
That's right. Each input value is paired with only one output value. Here's one more set. Decide whether this set of input and output values is a function.
So I look at the 3, it doesn't have just 1 arrow, it has 4 arrows. So that means right away, this is not a function.
Good job.
Let me know if you have.
Here are 2 new relationships. Tell whether each relationship shown is a function or not a function.
Okay, so I look at my x's. If my x's are all different, then that means it is a function. If they're not, then it isn't a function. So I look at this one, 53, 24, 20. See, they're all different. So that means it is a function. Now here, the thing that sticks out at me is that 8, the repeating 8. See, 8 goes to 21 and also 8 goes to 34. So there's 2 arrows coming out of the 8. You see 2 8s. So that means this is not a function.
Correct. The relationship on the left is a function, and the one on the right is not a function. The relationship on the right is not a function. Select the input value in the chart on the right that has more than one output value.
So right here, the 8.
That's right. 8 is the input value that has more than one output value.
So that's why that is not a function, okay?
It's also possible to identify functions from graphs. Each point on a graph represents an ordered pair. The first coordinate along the x-axis in each ordered pair is the input value. The second coordinate along the y-axis is the output value. The graph represents a function if each input value x is paired with only one output value, y. In this example, the graph shows the relationship between the number of hours students spent studying for an exam and the exam grades. The input values are the number of hours spent studying by each student. The output values are the exam grades. The points represent the ordered pairs shown. Point out all of the ordered pairs for which the output values y correspond to the same input value, x.
So for this one was easier for me to see whether it was a function or not a function because I used the vertical line test. So the vertical line test is that if you draw a vertical line, it only hits 1 point. But if it hits 2 points, then that means it's not a function. So see right there, that one and this one, they line up. So that means this is not a function. And then this one and this one lines up. So then this is not a function because there's two lines on that vertical, there's 2 points on that vertical line test.
Great. 2 is paired with both 70 and 85. 9 is paired with both 90 and 95. Is the relationship represented by this graph a function?
So it is not a function because the vertical line test hits 2 points, okay? If you do the vertical line.
That's right. This graph is not a function. Here's another graph. This graph shows the relationship between the width of a sticker and the length of the sticker. Is the relationship represented by the graph a function?
So once again, I draw a vertical line, it hits only 1 point. Another vertical line hits 1 point, 1 point. No matter where I put the vertical line, it's only going to hit 1 point. So that means it is a function.
Correct. The graph represents a function.
Okay, please let me know if you
Now,
have any
let's
questions, okay?
practice with the
So now let's do the yellow whistle. So there's no reason for you to not do well on this one, okay? Because I'm giving you the answers. It says select 4 different ways of representing functions. You can tell if a relationship is a function. So what ways that you can do? You can either do a mapping diagram, you can do a table, you can do graphs, and you can do an order pair. The output values, that means only the y values. The input values, that means only the x values. And you have to have both of them at the same time so that you can see them. So a relationship is a function if each input value is paired with only one output value. So each of those is only paired with one y. Each x is paired with only one y. Okay? Check it, got it done. So then the next one, it says a mapping diagram represents a relationship that contains 3 different input values and 4 different output values. Is the relationship a function? Completed. Now it says that there's 3 input values and 4 outputs. So that means that one is going to be going to 2 different ones. So it does not represent a function for the input values to be paired with all 4 output values. At least one of the input values has to be paired with 2, more than 1 output values, okay? So I check it and it is correct. Well done. And then I can just submit my answer and I got, right here, I got 100%. Thank you so much for watching. Okay, come here.